This presentation will be a discussion and presentation of dynamic rules in NORMA Pro. These are also known as behavioral rules or event rules. This is a relatively new feature that we're quite excited about. So NORMA Pro has had derivation rules for a long time. So what is a dynamic rule and how does this differ from a derivation rule? Well, a dynamic rule responds to an immediate change in the model with another immediate change. The first change you can call an event, the second one you can call an action. This is much different than a derivation rule, which can be removed from the model and completely recalculated based on the current state in the model. So for example, a derivation rule can create connections between existing objects or create subtypes of an existing object. It does not actually create an object. Also, there's no way with a derivation rule to track things like, hey, this object was created, because an object can also be removed at a later state. So you can't use a static rule to say, for example, give me the count of all objects in the system. So when processing a set of changes to a model, which we'll call a transaction, you actually have three different states for elements in that transaction. You have an initial state, which is everything that exists before that, before the transaction even began. You have a added state, so anything added since the transaction began. Then you have a deleted state, so anything removed. Your normal derivation rules always run on the current state, which is the initial state plus the added minus the deleted. So these can actually run technically outside a transaction if you want to do a computed rule, for example, because it's running on static state. So this relates to events because we're going to use these states to emulate an event declaration. So from a pure logic perspective, there are no events and actions. You only have states. And logic rules are an instruction to keep a consistent state. So you have the antecedent, the thing that, well, this is what I'm basing my consequent on, otherwise known as the body of the rule and the head of the rule. So the antecedent implies the consequent. Well, there's no eventing in here, right? These are states that must be kept consistent. So to do an event rule, you actually talk about these three states in a static format, right? So if you reference the added state in the antecedent, right, which is the thing implying, it says, well, let's treat that as an event, right? Because the added state in the antecedent says, well, something changed. The added state in the consequent, in the head of the rule, says, well, I better make sure that is also in the added state. But from a logic perspective, it just means keep these consistent. If this sounds confusing, it's really not something you want to deal with on a point and click rule entry engine, right? So to make this a little more accessible, we break both of these states, the static or the added state and the deleted state, into two pieces, right? If you say, hey, I have the added state and it's an event, then that means you're in the antecedent, you're in the body of the rule. If you're an added state and you're an action, that means you're in the head of the rule. All right, so using this mechanism, you don't actually have to reference rule bodies and rule heads. You just say, well, what state do I want to be in? And by breaking those added and deleted states into two pieces, the NORMA engine can actually determine whether you're in the antecedent or the consequent, so you don't have to say those terms or worry about them. So basically this way we're taking a static declaration that relates initial, deleted, added states and interpreting these and presenting them as events and actions. So the dynamic rules in NORMA use the same base construct that we do for the derivation rules. You start with an object, you path off that object, you split it, you OR it, you AND it, you connect the objects with the path any way you want to. You then follow that up by annotating that path and nodes in that path with different states. So you want to say, well, this is in the added state, this is in the deleted state, this is an add action, this is delete action, this is an event, etc. And then based on some reasonable validation restrictions on that path, and on your different states, we can determine the rule for you. So there are a number of restrictions. I'm not going to list them all here, but for example, you need one action and one event, right? I don't care if it's added, deleted, what it is. You can't have actions under or. You can't say, well, when this happens, do this or that or that or that, right? You have to have a single consequent. However, you can have or branches, so you can have multiple things that produce that result. The only requirement on the or branch is that each of those must also have an event in it. Some reasonable things: if you add an object, it has to be identified, right? So either have an auto identifier for your dynamically created objects, or populate the identifying fact type. And then other things like if you have an added role player, so it doesn't exist in the initial state, you can't reference that in a fact that is added or deleted. Or sorry, initial or deleted. Otherwise, it doesn't make any sense, right? So it enforces some consistency among your nodes. And this is actually a lot of the error state you'll get feedback on when you're clicking these rules in. Anytime you see an error in the verbalization browser while you're saying, hey, is this making progress? You click the error, it will take you to the node in the tree where you're having problems. So let's go ahead and take a look at this on a couple of straightforward dynamic rules.
So the first rule we're going to do is just a very basic subtype enforcement. So in this case, if this is turned off, realization is required by tailoring, then this must also be turned off. That avoids the error. So we add a dynamic rule. And as again, we're just doing looks just like a derivation rule path. So let's find a subservice type. Okay. And we want the tailoring. And we want dependency. Okay. So at this point, if I click on this and you look at the verbalization, it says when for some subservice type, that subservice realization is required by tailoring and that, right? It really doesn't make any sense because we haven't put any state into this. So let's add some state. So the subservice type itself, we don't care about that node. What we care is that when this is deleted, right? So when we have a deleted event on the tailoring, that we have an added or a deleted event, delete action. So here we have delete action as opposed to deleted event. And my delete action, the error cleared. If you click on that again, we should see a clean verbalization. So for each subservice type where that is deleted, your action now will be to delete this other part. Okay, so the next one we want to look at error state objects. I'm not going to do the error state object itself. Let's just look at subservice error. So I'm assuming that we've put enough rules in to add and create an error state if we want to. And let's look at this state. So the first thing we want to do is let's add a couple just normal rules here, right? So if I have a subservice error, it has the has missing service if, right? So let's start from the error, subservice error. We want to get the subservice, and now we want to say that subservice has a let's get this. Okay. So now our derivation rule says we have a missing service if it's hosted by some service. That's actually backwards. Clearly we want to negate that. Okay, so now we have an error on that. So when this object exists, it doesn't exist yet, but when it does exist, this will fit in automatically. So this one we want to do the same thing. We're adding a derivation rule. We're going from subservice error, and we want to get to the subservice. From the subservice, we want to get to type, and then we want to negate that fact type. Okay, so now we have our two derivations on there. But again, the derivation only applies once the object exists. So let's assume error state exists. Now we have to create a dynamic rule because this doesn't exist. Right, so let's assume the error state exists. Let's go ahead and create this fact. Okay, so let's add a new dynamic rule here. The objects we care about are the error state, which we need to have existing before we can create the subservice error for it, and the subservice. So what we care about are the states and the service types, the parent service and the service type added or not. Those are the things we're looking for. Okay, so when the subservice is created, if these objects aren't there, then we need to move it. So there's also one that needs to run when the different errors come and go, right? But for now, we're just going to create the object when it's there. So let's start from the error state. We're going to continue or coexist with a subservice. Okay, now what do we care about on the subservice? Okay, we care about the service. Okay, so it's hosted by a service. That's our first fact. Okay, our second fact is that we care if it has a service type. Okay, and now we want to hook up to the error state. Okay. And what error state do we care about? Well, the one that we grabbed that's existing from beforehand. So let's go ahead and hook that error state in. Alrighty. So now what are we going to do with this? Well, this is clearly an add, right? We want to add that state. So that's an add action, right? This is the condition if this is not there. So it's negated. This is negated. The subservice itself is added. So when this is added, if you don't have the other parts added, do something, right? Okay, so if we have an added subservice and an error state, this doesn't say added in front of it, so it's just the error state. Where that subservice is hosted by no service is added. Okay, this is a little confusing, and we'll improve this verbalization. So essentially what this means is that subservice is hosted by some service is not added. Okay, so that's the add. We've created it. Clearly, if you are existing and then you add the events, so if the subservice is initial and any of those events fire, you want to make sure that the error state is added as well. So this is just the one. I've added a brand new subservice. Let's make sure I have a subservice error. So this rule is called let's just call it error for new subservice. Okay. Now we want to do a deletion, right? So when do I want this thing deleted? So I have an existing subservice error. This is deleted. This is deleted. When they're all deleted, get rid of the error. Okay, so now I can create another rule to do that. So again, this time we're just starting from the subservice error, from the error itself. Okay, so let's grab the error. Okay, and now we want several things in there. Let's get the, we're missing the service. Okay, and type. Okay, both of these are going to be negated. Okay, so far I haven't done any eventing here, right? I just have a subservice error where both of those are true. So that's my full condition. Clearly that can be grouped into another derived fact, but we're not going to do that here. Okay, so now is where we get into the error, right? So what I want to do actually is delete this. So we're going to move this to the delete action. Right, and now I need an event. So I need to now say, let's get one event in here. Missing service. Okay, and now we want to say this is deleted. Okay, so let's see what that says. So if the missing service is deleted, now clearly we also need this, right? So let's go ahead and add one more, but now we want to OR these together. All right, so we're going to, what did I do first? Type. Subservice type. And if this is deleted, okay, so now what do we have? Those are all ands. Let's go ahead and change this to an OR. So if any of these events fire, and so this first part says everything's off. This says this will trigger. Notice this is an OR with events in it, right? So I can do this under disjunction. Okay, so none of my derived unaries are set, and when one or the other is deleted, go ahead and delete that subservice error.